So hi guys, welcome to today's tutorial. This time we are solving this question 4 from the worksheet 5. We have our function f of x here defined as a piecewise function. And what we need is to find two constants a and b such that this piecewise function is differentiable for all values of x. So let's take a look. Now, firstly, we know that this function is composed of a rational function and a polynomial. So write this here. Function composed of a rational function and a polynomial. Right. So we know that both of these functions are differentiable on their domains. They are already differentiable. Both of which differentiable on their domains. So to be more specific, in other words, except for x equal to 2. The function will be differentiable for all values of a and b. Right. So it means that for this function itself, right, is already differentiable. And for the lower function here, this polynomial function is also differentiable. And we know that when x is less than 2, we're taking that rational function. And when x is greater than 2, we're taking the other function, which is the polynomial function, both of which are already differentiable. So this discussion means that the only point that might potentially has problem is the point x equal to 2. So except for x equal to 2, we're all good. So what we need to do is just to focus on the point x equal to 2 to discuss the differentiability of the function at the point x equal to 2. Right. So that is the discussion. But there's another thing that we need to keep in mind, which is you know that the hints as that use the first theorem in class you're supposed to prove. That is, if a function is differentiable at a point, then it has to be continuous at that point, because differentiability implies continuity, but the other way around is not true, right? So let's write this down. However, before we take the derivative, we call that for f of x to be differentiable, it first must be continuous, right? So hence we start with we know that what a function being continuous at x equal to 2 means, right? It means that the left limit of this function is equal to the right limit, which is also equal to the value of the function at this point x equal to 2. So let's write this out. Left limit x x approaches 2, right? This thing has to be equal to, you know, the limit from the right has to be equal to the value of the function at this point, right? But what is all these things? Let's work them out. That is, for the first one here, limit x approaches 2 minus f of x, right? We're taking a look at the function from the left, so we should be using the formula, the rational function, which is x squared minus 4 over x minus 2, okay? And we just substitute, but you can't, right, before you cancel out the zero factor We know that there is a 0 factor here to cancel x minus 2, x plus 2. Right? Get rid of this factor, and then we substitute. We have 4 here, right, for the left limit. And also we compute the right limit, that is 2 plus f of x equal to 2 plus. From the right, we are using the blue function, the blue circle there. I hope that you can see that, the blue circle, ax squared minus bx plus 3. So ax squared minus, let me double check. Okay, that's right. And then we plug in. So we have 4a minus 2b plus 3, right? And then also check the f2 here. f2, that is equal to, what is that? Yeah, based on the formula, the expression, we're still using the rational function. Sorry, the polynomial function. b plus 3. So these three things has to be equal. Right, this 4 has to be equal to that, right, has to be equal to this. Therefore, we must have this 4a minus 2b plus 3 equal to 4. That's the first equation that we have to help us solve the value of a and b. But you know that we have two unknown constants here, and we only have one single equation, which is not enough for us to solve this. So we will need another equation to help us to establish a system of linear equations, which is derived from the differentiability. We're using the differentiability right now. So know that what does it mean by a function to be differentiable at x equal to 2? It means the derivative of this function exists, right? What does that mean by the derivative exists? Know that the derivative is just a limit by definition, so it means the limit exists. Now let's take a look at this. Write this out now. We look at differentiability. Right. The derivative of this exists means limit h approaches 0, f2 plus h minus f2 over h exists. What does that mean? That means, just means limit exists. It means the left limit has to be equal to the right limit. So left limit, this one, has to be equal to the right limit. 0 plus 2 plus h. Now let's substitute to work this out. We have our left limit. Notice that h here is approaching 0 minus, so h is a negative number. Once h is a negative number, 2 plus h is less than 2, right? Since h is less than 0, you have something less than 0 to plus 2, so it gets smaller, so it's less than 2. What does that mean? When it's less than 2, it means that for this f, we should be using the rational function, right, for the left limit. And for the right limit, since h is approaching 0 plus, which means that h is a positive number, and then f2 plus h there, 2 plus h is greater than 2. Once the input is greater than 2, according to the expression, we should be using the polynomial function. Limit h approaches 0. We're using the rational function, so I have x squared minus 4 over x minus 2, right? Minus f2. We've known f2 from previous discussion, right? f2 is this expression, right? Which is also equal to 4, right? By continuity. So f2 is just 4, right? This is f2. So 4 here, altogether over h. Notice that for this expression, we can use the difference of square formula to cancel out the factor, just like what we did here before, right? Cancel out this x minus 2. In this case, x is just replaced with 2 plus h. So the same thing is true if you use this formula, you can get rid of the factor in the bottom. So we are left with only x plus 2. X plus 2. Forgot the sign here. So x in this case is 2 plus h, so it's 2 plus h. Okay. Plus 2. And minus 4 altogether over h. And from here you see that the 4 can be cancelled, and after we cross out the 4, we can also cancel the h. So the limit here is just 1, right? H over h, which is equal to 1. That is our left limit. Now let's take a look at our right limit. So for the right limit, limit h approaches 0 plus, and as I mentioned, since h is greater than 0, so we can see that 2 plus h is greater than 2. So in the expression there, f of 2 plus h, we should replace f with the the polynomial function, right? Because x is greater than 2. So let's choose the polynomial function. What is the polynomial function? Let me take a look. ax squared minus bx plus 3. So it's ax squared, which is h plus 2, squared minus bx, h plus 2, plus 3. All right. This thing minus f of 2, we know what f of 2 is, which is 4a minus 2b plus 3, based on the discussion, right? And these things altogether over h, right? We open the bracket. See that this becomes ah squared plus 4h plus 4 minus b times h plus 2 plus 3, right? Minus 4a plus minus 2b plus 3. This thing altogether over h. Firstly, we see that this 3 here cancel out with this 3 minus, right? And also if you multiply this b through to this 2, this 2b cancel out with this 2b here. This 2b here, right? You got cancelled. And also this 4a here, minus 4a, it will be cancelled with the 4a obtained here. If you multiply a through, you have the 4a here. So based on this, let's write that out so that it won't be very vague, right? So I have a h squared plus 4a times h plus 4a minus bh minus 2b, right, plus 3, and minus 4a minus 2b plus 3. And as promised, this 4a cancel with this 4a, and this 3 cancel with this 3, and this 2b cancel with this 2b. Okay, so we are left with ah squared plus 4ah minus bh altogether over h. And we can actually factor out h from the top. So we have ah plus 4a minus b altogether over h. And we can cross this out so that we don't have zero factors anymore. Then we can just plug in h equal to 0. So we have 4a minus b. Right, so that is our right limit. Now remember, the left limit has to be equal to the right limit. So we have this right limit equal to, just copy and paste. Going back, we know that the left limit was just 1. So this one here, right? That is another equation we obtain by using the differentiability. Now go back to our previous equation we obtained by using the continuity. That was this guy here. Okay, so let me just copy and paste this guy here, so that we have a system of equations to solve, right? And if you solve this, you easily obtain that a is equal to 1 over 4 and b is equal to 0. Right? So that is the final solution. When a is equal to 1 over 4 and b is equal to 0, f prime of 2 will exist because the left limit will be equal to the right limit, right? So the function f of x will be differentiable at x equal to 2. And since f of x is already differentiable at the rest of the point, so that means f of x is differentiable for all the x, okay, all values of x. And now let's also take a look at this question from the workshop 6. That's about the implicit differentiation, which will show up in your next term text. So now we have a function given by this equality here. So the function was given implicitly. You don't know the explicit expression of the function y equal to something in terms of x. We don't know that. But you were asked to find the derivative without actually knowing what this function actually is. So that's called the implicit differentiation. We basically make use of the chain rule to find this. So if you're still having trouble with the chain rule, make sure to review it before doing this. And now let's get started to see how this work out. So we have this thing here, right? Sine y plus y3 equal to x 2y2 plus ln x minus 1. The first step to do is to take the derivative with respect to x from both sides. So take the derivative with respect to x on both sides. Right. We have for the left hand side here, you have sine y, right, plus this y to the 3, so it will be dx of sine of y plus y to the 3 equal to d of dx x squared y squared plus ln of x minus 1. This symbol d of dx means the derivative with respect to x. Now we distribute this differential sign over the sum on the left hand side, so we have d over dx sine of y plus d over dx y to the 3 equal to d over dx. Just distribute this over the sum. That's the sum rule. Ln of x plus d over dx negative 1, right? Now let's take a look at the first term here, d over dx of sine of y. We're gonna view this as a composition of two functions. So I write this out just for educational purposes, but in the exam you don't have to if you've already understood how this works. So this sine of y is viewed as a function u equal to sine of y, right? So it's a function of y, and in the same time y is also a function of x, but this is kind of implicit relation. So y is equal to, for example, y of x, something like this, right? Well, we don't know what this is implicit. So this d over dx sine of y is actually du, d over dx du, which is du dx, right? And by the chain rule, we know that we can insert one variable in between u and x. So that's gonna be y, right? So it's gonna be du over dy times dy over dx. Right? We know what du over dy is based on the thing here, right? U equal to sine of y, so that is equal to cos of y. Right? And dy dx, we don't know, and that is the thing we're looking for. So keep this here, dy for dx. Right? So the reason I'm writing this here is just to tell you that d over dx of sine y is obtained by using the chain rule. And the answer is cos of y times dy dx. Okay, so after this explanation, and we just put this somewhere else, right? So we know that the first term here on our left hand side, that is supposed to be our cos of y times dy over dx. Then we plus, for the second term you do the same thing, but this time the function u is equal to y to the 3, right? U is a function of y and y is a function of x, so you will be using the chain rule. If you don't like the letter u, you can use v or whatever letter you like, but it doesn't matter. So by the chain rule, it will be the derivative of the outside function, which is y to the 3, so it will be 3y squared. But since this derivative is with respect to x, not with respect to y, so we're gonna look at also the second layer, which is the derivative of the inside layer, right? This y of x, so dy dx times dy dx. That's where this comes from the chain rule. And now on your right hand side you have this thing, right? So product rule gives us that this is equal to d over dx, the derivative of the first factor times the second factor plus the first factor times the derivative of the second factor. So this, right, the chain rule. And for the next term, ln of x, we know that very clearly, that is 1 over x, so plus 1 over x. And for the negative 1, that is a constant, so it's going to be 0, okay? It's going to be 0. So continue to work this out. Cos of y times dy over dx plus 3y squared dy over dx equal to the first term here, this guy is gonna be 2x times y squared plus x squared times this d over dx y squared. That's again chain rule, because y squared is a function of y and y itself is a function of x. So you're gonna realize that the outside function, the most outside function here is y squared, and the inside function is y equal to y of x. So that's times 2y, which is the derivative of the first layer, times the second layer, which is our dy over dx, right? That's called the implicit differentiation. We don't know what the second layer is. We don't know its derivative, and we're using the chain rule to find out this based on the equation we have. So now we have everything ready. Just finish our differentiation. Now the second step, the next thing to do is to collect these terms. Okay, we're gonna recognize them here. I'm gonna view this as a variable or as an unknown in this equation, and I'm gonna try to solve this equation, right, and view other things, everything else as constant, just like how we handle equation of x and solve for x. So this for this red circle here, you will view this as x and solve for x. So since we're solving for this, we need to move everything that has this factor to the left hand side. So I'm moving this red circle to the left hand side here. So I have cos of this dy dx stays the same, plus 3y squared times dy over dx, the same. And then I move that term to the left hand side, so it's minus 2x squared y squared, right? Just simplify this a little bit, dy over dx equal to the rest of the right hand side, 2xy squared plus 1 over x. Now I'm gonna factor out this thing, dy over dx. Since I'm solving for this, so I need to factor this out. So cos of y plus 3y squared minus 2x squared y squared bracket equal to 2xy squared plus 1 over x, right? I can divide both sides by this guy so that I can solve for dy over dx. So do that. Dy over dx is equal to 2xy squared plus 1 over x over this cos of y plus 3y squared minus 2x squared y squared. And so this is our final answer. We don't have to simplify this anymore because we're not using it for anything else. Just solving this, right? Looking back to our equation, okay, actually we do, right? Find dy over dx, and also need to find the equation of the tangent line at the point this E0. So we're gonna find the slope, right, first, and we know that the slope is just the derivative. So we can plug in this E0 to this expression here, right, to find out the dy over dx exactly at this point. So find this out, plug in xy equal to E0, that is equal to x is e, so we have 2 times e, right, times 0 plus 1 over e, right? This is cos of 0, right, plus 3 times 0 squared minus 2 times e squared times 0 squared. Simplify this, so we have 1 over e on the top, and the bottom we have a 1 plus 0 minus 0, which is 1 over e, right? So that is the slope, this is the slope. And recall that the equation of a line, I'm talking about the point slope form, that is y minus y0 equal to m x minus x0. Just a little bit review that x0, y0 is the point this is L, okay, that the line L is through. So it could be any point as long as the line is through this point, you can use this. And since we're talking about the tangent line at this point E0, so we can just take this x0, y0 as our E0, right? We can use this point because it's the tangent point. And also we have this slope m here is the slope, right, equal to 1 over e. Now we have everything ready. Just plug into the the equation 1 over e. Maybe use another color so it looks a little bit better. So plug in, we have y minus y0, which is 0, equal to m. M is our 1 over e slope, x minus x0, which is e. Okay, that's the final answer. We don't have to simplify it because the question does not specify which kind of form of a line we're looking for. So we can just give this form. It's the slope point slope form, normal form of the line, which is acceptable. So that is this question. And to summarize, we need to use implicit differentiation that's obtained by the chain rule. So the chain rule is the foundation. And also the key point of finding this is solving for the derivative without actually knowing what the explicit expression of the function. So that is what is new here. And for the tangent line, that's just exactly the same as the stuff we have dealt with before. You get the slope is the derivative, right? And then use the point slope form as before to find this out. So that is the summary. So that's it for today. If you like my videos, make sure to subscribe to my channel. I'll make more videos about that in the future. So see you guys in the next episode.